In addition to wanting to know where some data is located on a number line, we also like to know how spread out is the data. Is it really clumped up in one location, or does it spread very widely? Now, there's two basic measures that we use to figure this out. The first one is the range. Now, the range is simply taking the max value minus the min value, so it tells us how far spread the data is. However, it doesn't tell us if it's just one or two data points out sitting alone and then most of the data is in the middle, or if it's really all spread pretty evenly over this area. So in order to get a better picture of what the data might look like and how clumped up near the middle it is versus like all over the place, we use a thing called the standard deviation. So we're going to take a look at how to compute both of these things and take a look at an example of finding each. So when I'm considering a data set, the range is the max from that data set minus the min from that data set. It's fairly easy to compute and it gives us a basic picture. The interquartile range can sometimes tell us a little bit more, especially in conjunction with the range. So to find the interquartile range, I have to find my third quartile and my first quartile. So that's my 75th percentile and my 25th percentile. And then I take the difference between them. And what this does is it tells me where the middle 50% of my data is located. And that gives me an idea of how close together my data might be, and it doesn't have quite so much the problem of the range of having one or two data points that are far flung and then increasing the entire measure. So there's a few steps involved to calculate a standard deviation. It's really 3 steps. So the first one is you're going to take every number in your data set and you're going to subtract the average from it. This is going to result in either a positive or a negative number. So if the data point was above the average, it'll result in a positive number, and if it was below the average, it'll result in a negative number. Now, the fact that these deviations can be both positive and negative makes it difficult to combine them in a meaningful way because they'll start canceling each other out. So what we do is we square each of those numbers, and in doing so, we make them all positive. This also has the added effect of if the deviation is less than 1, so the data point is very close to the mean, squaring it makes it smaller and less impactful. And if it's more than 1 from the mean, so farther away than 1 from the mean, squaring it is going to make it larger and make its impact seem bigger. So we're going to square these numbers, and we're going to now have this collection of squared numbers, and what these are called is squared deviations. So now that you have this collection of squared deviations, one for every number in your data set, you're going to find the average of the squared deviations. So that means you're going to add them all together, and you're going to divide by the number of data points in your data set. When you do this, what you will have done is calculated a number called the variance. So the variance is the average of the squared deviations. And the final step to get to the standard deviation is to simply take the square root of the variance. So we're basically taking all of these squared deviations, we're finding the average squared deviation, and then we're taking the square root of it. That takes us back to like an average deviation, or what we call our standard deviation. This value tells us how spread out the data is from the mean overall. So this actually takes every data point into consideration, unlike the range or the interquartile range. So this is a very, very powerful way of thinking about how spread out our data is. Let's take a look at an example. So here I have 10 homework assignment scores. They range from 85 to 95. So if I want to find my range, I simply take the largest one, so 95, my maximum, and subtract my minimum, or the smallest one, 85, and I find that the range is 10. And that's how I would report that. The range is 10. Now, if I wanted to report my interquartile range, I'd need to find my third quartile and my first quartile and subtract them from one another. Remember, my median, my 50 percentile, is in between these two values here. So it would be our 5.5 value in our data set because we have an even number there. And now if I take my first quartile, I would end up with the number 87. If I take my third quartile, I'd be at the number 93. So if I'm looking at my third quartile minus my first quartile, I'm looking at 93 minus 87. So this is going to equal 6. And that's how I would report that. The interquartile range is 6. Now, we're going to put in the work now to calculate the standard deviation. So the first thing that we need to find our standard deviation is the average. So my average value is going to equal the sum of all of these divided by 10. So I'll have 85 plus 86 plus 87 plus 88 plus 89 plus 91 plus 92 plus 93 plus 94 plus 95 divided by my 10 scores. So I'm going to end up finding out that my average is 90. And I'll be using that. So the first step to finding the standard deviation was to find all of the individual deviations. And I found that by taking my x value and subtracting from it my average value. So I'll be subtracting 90. So for each of these values, I'm going to find x minus 90. Now that I have each of my deviations, the next step was to square the deviations. So I'll be taking x minus 90, that quantity, and squaring it. Or in my table, what that's going to look like is taking the value that's in my second column now for each x value and squaring that. So I'll have negative 5 squared and so on. Now that I have all of my squared deviations, you can notice that my deviations themselves told me what direction the data point was from the average. And the squared deviations now, it doesn't matter what direction they are, it's telling me about how far they are. So the squared deviation for the score of 85 and 95, they both have a squared deviation of 25. So my next step was to take the average of my squared deviations. So that average was going to be my variance. So the average, I find that by taking all of my squared deviations, adding them together, and dividing by 10. And when I do that, I find that my variance is 11. So the average of my squared deviations, or my variance, is 11. So the last step that I had to calculate my standard deviation was to take the square root of my variance. So I'm going to take the square root of 11. So this is going to tell me that the standard deviation is about 3.3 points. And that's exactly how I would report that as well. I would say the standard deviation is about 3.3 points. So we have our range, our interquartile range, and our standard deviation, all describing to us how spread out this data is.